Hi everyone. So today's topic is going to be around light. This is from our classroom in Jaipur. This is my first stream, so I'm going to be checking how it's going to work out and if it's all right. So yeah, so just let me know if the audio is clear, if everything's clear. I'm also learning the ropes of it. But yeah, so we're going to be together for about 40 minutes. And yeah, I'm happy to answer your questions. You can reach out to us directly on it. Uh, the phone number and the and the things that are available. But other than that, please feel free to email us, WhatsApp us, or you know, just let me know. So whatever medium that you prefer. So today's topic is light, which is reflection and refraction. And I'm starting the series so that the students that are struggling with physics especially can always come back to me and talk to me about it. And give me a second. I'm not sure how it's looking over there. So the webcam is seems opposite. Reaction. Really trying to work something out here. I hope it's looking fine. Not sure why it's showing that way. Yeah, so I'm trying to see if I can get the link. Just checking if the stream is all right. I know it's going to take me some time to technically figure it out, but yeah, I hope you're with me. So yeah, so this chapter is quite interesting, super interesting, in fact, according to me. Talks about talks about everything under the sun which comes forth, right? It's about light. It's about how we see. It's about how we understand things around us, or rather, our brain understands things around us with respect to light. And at the same time, it's about talking to talking to each other about how light works, because everyone has eyes but we don't know how they work, so it's quite stupid that way, but it's also incredibly important. So yeah, still working it out once. All right, it's perfectly fine. I can see that. So yeah, let's start now. So it took me some time to figure it out. Yeah, so this chapter is very fascinating. It's all about talking about light and reflection and refraction and how it works and what we do in them and what are the details that go into it. Right. So we'll first start with reflection, and then as the chapter progresses, we'll go into refraction. So reflection is bouncing back of light. Alright, bouncing back of light from any surface. Alright, the surface does not matter. It can be liquid, it can be solid, it can be any kind of other surface also. In fact, it can be smooth, it can be irregular, however it works. But it has to be, the light has to be bouncing back. Alright, now bouncing back into the same medium. That's again an interesting and important part of it. Okay, so that's what reflection is about. And so we'll dive deeper into it. But before that, let's talk what light is and how it's important. Okay, so that's again another key thing that we need to first understand. Because light is this whole branch of physics is called optics, which is everything related to light. Okay, and it's become over the years it's become quite a huge subject because we talk about eyes in it, we talk about lenses, we talk about you know everything that we see, then telescopes, then astrophysics. Even in astrophysics, all the telescopes are required, and then microscopes. So in biology also it comes into play. So I know we make the technology or the outcome of it through physics, but then the applications of it can be anywhere. And that's where optics as a field has increased quite a lot and become quite wide and detailed. So within optics, mainly there's reflection and refraction, and then there's the third one, which is chromatography, which also comes into play, which is about how colors play a big role into our life. All right. Now, chromatography is also there in chemistry, and that's more on a molecular scheme, or rather molecular as in how certain substances have certain colors. Here we talk about how we see those colors or how light has different aspects of the colors. Right? So that's what optics kind of fathoms in. Now where all is it used? I've already given some examples, but today the most important place that we're using it in is internet, which is how you're seeing this particular live stream as well, or the video. Either way. So internet runs on something called fiber optics, and this fiber optics is based on the principle of refraction and total internal reflection. Okay, two things: refraction and total internal reflection. All of this, I mean, and both of these things we'll be studying in this particular chapter, and we will also be taking fiber optics as an example towards the end of this chapter, or in the second chapter, which is human eye, because that's where the majority of the applications are. But you can see and use, and we are doing that in real time right now. We're seeing the effect of this particular chapter right in front of us. All right. Then the second one, that is again the most important invention you can say in recent times is our eyeglasses. And I'm saying most important because it's become so common, so natural for us to wear or to have eyeglasses with us. So that's where eyeglasses come in. So eyeglasses are simply, uh, based on this concept of refraction again and lenses. Now, these are almost one and the same thing, but refraction is the main concept over here, which comes into this play. Okay, so these are the things that we'll be discussing, and of course, there are so many more applications. We talk about, light emitting diodes later on, although that's also linked to electronics. But so another cool thing is we won't be discussing it in detail, but it's an experimental technology that's into play right now, which is LiDAR. Okay, The full form you can search online very easily, but this is essentially what allows autonomous vehicles. So, autonomous vehicles. Okay, so it allows autonomous vehicles to move quickly and map the surroundings almost at light speed as to how we work, right? So how we work or how our eyes works is we are able to see things in front of us. And similarly for applications of our say smart cars or whatever new technology is coming up, in order for them to see the surroundings, they essentially throw out a lot of light rays which are invisible to us, which are called ultraviolet light. Those light rays essentially reflect back to the car or to the vehicle, and then it creates an image, 3D image, real-time 3D image of what's out there. Okay, and all of that calculation and complex algorithms run in a fraction of a second in order to create that picture for the car and accordingly take the decision to go straight, stop, take a right, whatever the situation is. Okay, so LiDAR is very important nowadays, and also as satellite internet comes into play, LiDAR is coming into play over there as well. So we've seen Starlink. Starlink, which is the upcoming technology for satellite internet, which is also getting super popular because of Elon Musk and Tesla, and SpaceX. So Starlink also uses LiDAR in some respects. Obviously, it's not the entire thing through and through, but in some respects. Right? So let's dive deep into this particular topic and understand how something that you learn in 10th standard and that we take for granted in 10th standard, rather how it is actually getting applied into the world around us. So, reflection, coming back to this. So, I'm just going to read from the book as well. There are two laws of reflection. First, angle of incidence is equal to angle of reflection. And second, the incident ray, the normal, and the reflected ray all lie in the same plane. Alright? So, two important things here, laws of reflection. First one, angle I is equals to angle R. So, this is the first one. Now, why is this important? Because angle I and angle R is how we define them, right? And how, according to our definition, and then experimental truths, and of course some derivations as well, we've come to this conclusion that this is always true where true reflection is happening. Okay, let's see how that works. Suppose I have a plane mirror, and always, if you have a plane mirror or any kind of mirror for that matter, please shade the part which is not the reflective surface. If I just make a straight line, you would not know which is the reflecting surface and which is not the reflecting surface, and that's why the shading part is very important, and especially in terms of the exams, you have to do this, otherwise you will make a lot of wrong diagrams. Now this ray which is coming towards the mirror, okay, the ray that is coming towards the mirror is called the incident ray. The ray that is coming towards the mirror is called an incident ray. Now, from here, this point, a single point, not the arrow, okay? This point is called the point of incidence. Incidence. This is point of incidence. At the point of incidence, we create an imaginary line like this. And this imaginary line is always perpendicular to the surface. So we create an imaginary line which is perpendicular to the surface at the point of incidence. And that imaginary line is called the norm. And I keep saying imaginary because it is truly imaginary. It's not there in real life. You won't see it if you have like something reflecting off a mirror, but you will. We have created it in order to understand reflection better. Okay, and that's why I said we define these angles in a certain way. And then we have the reflective ray. Okay, then we have the reflected ray. So we have the incident ray, the light coming in, the light ray coming in, the point of incidence where it is bouncing from, and then the reflected ray where it is bouncing to, or in which direction. And in between we have the normal, which is an imaginary line perpendicular to the surface at the point of incidence. This language is very important. The normal is an imaginary line perpendicular to the surface of the mirror at the point of incidence. Okay, this language will be used again later on, and according to that only the definition of angle I and R, which is angle I then becomes this angle between the normal and the incident ray, and angle R then becomes this angle between the normal and the reflected ray. Okay, this is how we define these angles. So again, understand what definitions imply. Definition means that we've put something into a very clear box, and whenever it is in that box, only then we put a name to it. So if I say this angle, I know for sure that this angle will not be called angle of incidence. Why? Because I've put a very clear box around angle I. That angle I is the angle between the normal and the incident ray. So I put it from my end even before anyone else came in, right? So the moment I say that it's the angle between them, now the angle can be, I can make the angle here, angle between the normal and the incident ray. All of these angles are the same, correct? And there is no other way that I can create this angle. Okay? All the other angles, this one, all the other angles are some other angles. They have their own names, but they are not the angle of incidence or the angle of reflection. Okay? So this is an important understanding and something to keep in mind, that angle I and angle R need to be here, and they are very clearly defined, and you need to know the meaning of definitions and how we use them in physics and science everywhere. So the first law of reflection is angle I is equals to angle R. Okay, so we come up with that, and that's the first thing that we need to know. Now obviously there are derivations for everything, and I'll probably come to that depending on the time. But at the moment, I'm just discussing about the law, and then I'm going forward. Next is incident ray, reflected ray, and the normal all lie on the same plane. Another important thing to know, to understand, to be very clear about. Okay, now these are all things that you have to imagine. There is no, I mean, obviously you can see videos and animations, but at the end, the whole thing that they're trying to do is for you to imagine something like this. So let me quickly find another pen. I have it. So I hope you can see it clearly. I've got everything in blue, unfortunately. But yeah, so I have this pen. So if I say that this pen, this blue pen, is my incident ray, this black pen is my reflected ray, and I add another one over here, which is say the normal, right? Now, what this statement says, or what this law says, is that all three of them need to be on the same plane. And by same plane, we mean that if I put a piece of paper behind it, or like how I put my hand behind it, all three of them will touch that plane. That's the important thing. Okay, so that's the important part about the plane surface. So all three of them, incident ray, reflected ray, and the normal, all lie on the same plane. This is important because a ray which is not on the same plane, it can just go anywhere, and the angle would not be defined properly. It's more on this line, but the angle would not be defined properly. That's why it is true. Okay, so these are the two laws of reflection my bad. So yeah, and as I said, the reflection can happen from any kind of surface. It can be plane, it can be spherical, it can be conical, it can be anything. It can also be rough, it can also be smooth, any kind of surface over there as well. All right. So for today, because it's the first time that I'm trying this, I'm going to stop it here, but I'm going to continue from here in the next class. All right. So I'm ending this early, but that's just because I want to try it out first, and then tomorrow or day after, I'll do the next one. All right.